Okay, let's go ahead and take a look at general polynomials and theorems for real polynomials. Basically what we're going to be doing in this particular section is just taking a look at particular situations and either finding the roots or zeros, or given a particular polynomial with a given root, find the polynomial. Okay, so let's just go ahead and take a look at this for now. Let's just say that you wanted to go ahead and factorize this particular polynomial, which is x cubed plus 3x squared plus 4x plus 12. Now, generally speaking, when we wanted to go ahead and factorize, if we had a quadratic, it was very straightforward. We could always go ahead and use our various factoring techniques to go ahead and determine what those linear factors look like. But when it comes to a cubic, it becomes a little bit more complicated. Now, what we're going to have to do is we need to use some of the theorems that we know. And in this particular case, we want to say if p of k is equal to 0, then the factor x minus k is a factor of p of x. So by trial and error, and of course we can go ahead and use our graphing calculator to help us do this, we can go ahead and find out that -3, if we substitute that into p, then the polynomial p of x, then we come up with the value of 0. Therefore, we know that x minus -3 or x plus 3 is a factor of p of x. So if that's the case, now I know that this -3, if I use synthetic division, is going to give me this particular result here, which is the remainder, and also the quotient function there. So p of x then is going to be x plus 3, which is that factor, times by x squared plus 4, because that's the result of the synthetic division process. And then we can go ahead and take a look at x squared plus 4, and we know that that's going to further factorize to x plus 2i and x minus 2i. Okay, so alternatively now, we could have gone ahead and actually factored this from the beginning if we looked at taking the first two factors, the first two terms and the last two terms, and recognizing that there was a common factor between them. So if we go ahead and take a look at the first two terms here, if we factor out the x squared, we come up with the x plus 3. If we factor out 4 here, we come up with 4 times by the quantity x plus 3. Notice that the x plus 3 factors are the same, so we can factor that out, and we're left with x squared plus 4, which then factors to x plus 2i and x minus 2i. Okay, so generally speaking, we want to go ahead and take a look at the alternative method, because if we can factor it without having to do synthetic division and all this other trial and error to find out what a particular root is, then why not do that? But if you cannot, then you need to use some of these general polynomial theorems that we have in order to go ahead and determine at least one factor for the polynomial, and then go ahead and use division to find the other factors. Now, let's go ahead and take a look at another situation here. It says 3 minus 2i is a 0 of p of x. Find the polynomial of p of x. Now again, one thing that we want to go ahead and remember is that the complex roots always come in conjugate pairs. Therefore, p of x has to be equal to a times it by the two imaginary or complex roots which are conjugate pairs to each other. So notice I've already gone ahead and put these into factor form, which is x minus the quantity 3 minus 2i, and x minus the quantity 3 plus 2i, and notice those, again, are conjugate pairs of each other. Now, usually we can go ahead and do this, distribution using FOIL, but I would recommend doing one small change to make the FOIL much simpler. If we go ahead and distribute the negative to the complex numbers, and we regroup them as such as the quantity x minus 3 plus 2i and the quantity x minus 3 minus 2i, then you can have a difference of squares. So we have a times it by the quantity x minus 3 squared minus the quantity 2i squared, which is the same thing as 4i squared. So notice that we can then go ahead and very simply expand this as x squared minus 6x plus 9, and that is just going to be 4, to finally come out with an expression for the polynomial, the parameter a times it by the quantity x squared minus 6x plus 13, and of course we need to mention that a cannot be equal to 0. Okay, so what we're doing now is we're taking a look at all of the different situations that we have regarding the relationship between the roots, the zeros, the x-intercepts, and the factorized form of the function and the polynomial, and using all those to determine either the factorized form or to come out with a polynomial based upon particular conditions given by the roots or zeros of the polynomial itself. Okay, so we'll take a look at some of these problems the next time that we meet. Let's go ahead and take any questions that you have during that time as well. See you next time. Bye-bye.